So this is activity TT61, and it's in support that the stuff that I'm doing in class these days. This course being a CAD class, the intention is not to teach you finite elements in it. However, I want to show you how to do very simple problems uh, in the Catia's FEA solver. Okay, you should be aware, you should be able to do that for the final exam. These are not complicated problems that we're looking at, and we're not assessing the validity or the quality of the results that we generate based on the finite element analysis. So the problem that you see here is the edge of this circular thing is clamped, and on this uh, stand here, we're going to apply a total of 500 pounds on that circular patch on the very top. Now, the thing is that on the final exam, I will ask you to use all planes of symmetry that apply to this thing. In other words, what is the smallest unit of this object that I can take and analyze and extract the results that applies to everything else? If you think about it, if I do, for example, just one way is if I do, for example, a sector here, just a sector which is 60 degrees, 120 degrees, like that, and there's got a circle there in the middle between these two edges, which are 120 degrees apart, that this whole thing is going to get repeated 3 times. Okay? Or you can, if you want, take a sector that looks like that, half a circle here, go 120 degrees, and another half a circle there. Either one, they're acceptable. However, the first time I'm going to do this problem in this activity is to not use any planes of symmetry. But that's not going to happen on the final exam. It may not happen on the final exam. Okay, so let's go ahead and make this thing. I'm going to start with a part, and I'm going to call this thing TT61. Say okay. We're going to make it. So on that horizontal plane, I will sketch. And there are different ways of doing this problem, as you know, but I'm going to sketch a circle of radius. Based on the drawing, the radius is 10 inches. The radius of the big circle is 10 inches, like that. Make this thing 10 inches. A diameter 20 or the radius 10. Okay, fit it. Good. Exit. Exit. Pad it by 2 inches. There are many different ways of doing this problem. On that top plane, I'm going to sketch two things. One of them is a circle there, where the radius is uh, this this radius is 2 inches. Okay, so let's give it a dimension. We'll change this into radius, 2 inches. Okay, exit, pad it by 1 inch. 1 inch. Okay, and then I want to draw a pocket here and then pattern it using circular pattern, for example, on that top face, this face. I will sketch a circle of radius 1 inch, whose center is positioned 7 inches from the center of this big circle. So the center of this to that should be 7. 7. So okay. Exit, pocket it all the way to the end, to last, to next, either way. And I'm going to use a circular pattern to make two more of these. So let's see now. Here's a circular pattern. Read that thing carefully. I want to do a complete crown. And I want altogether three instances altogether. That includes this guy. And the reference element is that top face or the side face. And not the whole solid, but you just want the pocket. That's all. You might say, well, it looks the same. I understand. And it may not make a difference, but I want a pattern in the pocket. Okay. All right, good. Now we apply material properties. Incidentally, later on, I'm going to have to come and cut this thing, get a 120-degree sector out. Okay, and there are different ways of doing it. One is, I mean, obviously you need certain planes which are at 120 degrees, etc. There are different ways of doing it. We're going to do the easiest one that we can find. All right. So let's go ahead uh, and apply material to this thing. It says use properties of steel. So we apply material. There's apply material icon. Let's use steel on that piece and we say okay. All right, and save this. Or let me put it this way, let me not save it right now. I can go ahead and say file, save management, for example, and take you to the folder that I want to go, which is this week. Cancel that, but I'm not going to do that for a second. Okay. I advise you to do that on the final exam in case things go crazy. All right. So what we're going to do is to go to start, analysis and simulation, generative structure analysis. What Catia sees, first of all, is going to try to do static analysis, and that's what we want. That's all we do in this module of the class. Let me change the rendering here so that I can see things better. All right. Now, this is the element size that it's going to be taking. Double click on it. It's going to be linear, parabolic element. I'm going to change that to linear. This is the cheaper one. Or faster one, less accurate one, of course. And the size is, you can see it's like that. That's too big. You know what I'm going to do is I'm going to make this thing point maybe 5. And let's see how it looks like. Not only that, I mean, obviously I can look at my mesh. You can see that. Put the cursor on nodes and elements. Put the cursor there. Right click, mesh visualization, and say okay. And obviously, you're going to get something like that. I understand that. But let's say that we were also asked to do local mesh refinement around these holes. So first of all, deactivate this mesh. Put the cursor on the mesh, deactivate it. And then remember how you do local mesh refinement. You go to the model manager. Second icon is actually a toolbar, sub toolbar, and this says local mesh size. I click on that and I select this. Notice that it did put something there, very small. You can see that. And I do that, and say okay. And now if you say show me the mesh, put the cursor there, right click, activate, and wait for it to mesh. You can see that it has a fine mesh in these areas, but the rest of it is pretty much the same. It is the same, actually. It's not pretty much, it is the same. Okay. So I did the local mesh refinement here. And if you change your mind, you want a bigger local size, double click on this, change the number. I'll leave it like that. Because I'm using linear elements, which are very cheap and it doesn't take very long. Okay, so let me hide the mesh. When I say hide, I don't really mean it. I mean deactivate, because you can hide it and that's fine too, but the part is going to go also. So bring it back and deactivate it. Okay, good. Now we do the rest of the problem. Remember, model manager, you did local mesh refinement if needed, otherwise you don't need it. Restrain this edge, entire edge is clamped. I selected the entire edge. And then you apply a total force of 500 pounds on that stand. So you go to loads. Here is a distributed force, not pressure, distributed force on that face in the downward direction, 500. Okay? We say, all right? All right. Now, before you run, you save. No, you haven't saved anything yet. So you go there, you say file, save management, this thing pops up, and neither one of these have been saved. But if you save analysis file, save as, first of all, let me give it a name because I don't want it to get confused with this guy. I'm going to say dash TT61, and I say save. And there is this thing pops up, it says propagate directory. In other word, I have a file there, which is also not saved under this. Should I try to save both of them in there? So yes, the only thing is that well, let's try it. Propagate directory, say okay. Let's check that directory. That directory was here. This is the one that I just saved. See that? This is the one that I just saved. This is the one that I just saved. Uh, this is the analysis file. Where is the part? The part, this was supposed to be the part. Unfortunately, I think by mistake, I called it TT60. So let's go ahead and, right there. Sorry, there it is, not this. It's right there. You see that? TT61. So it also saved that. All right. And the reason I mentioned this thing is that if you had just not set propagate directory, it would have saved this, but this would have been somewhere else. Okay? Not saved and not necessarily in this folder. Propagate directory means part, also bring it here. Good. So let's go ahead down there. And finally, we're going to run it. Let me remind you that we already renamed our part as TT61. Okay. Now here's the calculator. Look at what happened. Model manager, restraint, where I put the restraint down here, load, where I apply the force here, and then compute. All, it should be all. Don't fool around with that. In this course, at least. And say okay. And let's see how it looks like. Let's see how it looks like. So here is the deflection, how it looks. You can animate it. That's the way it should be, right? That's the way it should be. You apply a force up there. This should go down. If you want numbers, you click on the displacement, double click on it. These are all arrows that you can see, downward arrows. You say change it to average ISO and change this thing to material shading. Material shading. That's the way it should be, right? You can still animate it if you want, so it's going to be like that. Good, good. And very tiny, small amount of displacement. That doesn't surprise you because a 2-inch piece of steel, 500 pound on it is nothing. If you want to see one meter stress right there. Now, you see that it's 124 psi is nothing. The yield strength for steel is about 30,000 psi. So it's mild steel, something like that. 30,000 psi. This 165, nothing. Good. Now, let me click on the save here. Right. Okay. Now I want to go and take symmetry into consideration by taking 1/3 of this basically disk. There are many ways of doing it. And if you are having a hard time, maybe approaching it the way I am doing it by spinning it with the appropriate surfaces or planes, And you may want to model this thing exactly like it is already to begin with, maybe one third of the model. But that's not how I'm going to do that. Here's my approach. I'm going to go to this part, to that original sketch that I drew. This was the original sketch, right? All right. So I will draw a 120-degree sector here. But unfortunately, the way it is right now, I cannot draw it in here. I cannot draw it in here. So what I'm going to do instead, I'm going to go up here. For example, on that top face, or on the bottom face, it really doesn't matter. I will sketch, or even on this top face, I will sketch. You'll see what I have in mind. I'll sketch two lines like this, one going this way, another one going this way, okay? And make these angles 60 degrees each. So let's make this thing 60 degrees. I could have drawn the line and then mirrored it, but that's okay. And then another one between this and that, also 60 degrees. 60 degrees, say okay. All right. So this is one third of the model, exit. Okay. And then I'm going to make a surface out of that and then use that surface to split this part with it. Okay. So what do I mean by this? You go to make a surface out of that, you have to go, as soon as you say surface, you have to go to uh, either advanced, either generative shape design, that's entirely up to you, or you can go to mechanical design, wireframe, and surface design. Remember, this is the stuff that we did 3 weeks ago. And then we extrude that sketch in both directions, okay, maybe longer, because I'm going to use it for cutting purposes, splitting purposes, okay? So I'm going to go back to part design, back to part design. So let's go back to part design and use the saw here. Here's the saw. It says, what is the splitting element? The splitting element is that surface. And do I want to say, take the left side or the right side? I want the other side. And you say, okay, and hide this. You can't delete it, you have it. So you do it any way you want. This is what you want. Already the material is on it, okay? So let me go to File, Analysis and Simulation. Not File, what I meant, Start, Analysis and Simulation, Generative Structure Analysis. Catia immediately measures that. You can hide that sketch later on if you don't want to see it. Here, this thing you can hide. This is coming from the sketch that we did. And if you want, you can change the rendering like that. Okay, already meshed it. Maybe I make a smaller mesh. Double click on that. I'll make this thing 0.5. All right. And if you want, you can make a local mesh refinement. This is only if you want it. I don't want to do that, but well, maybe I should. Local mesh size on here, 0.3, and I'll use maybe 0.1. You can see it, it's right there. See that? See the tiny thing? And if you want to look at your mesh, this is going to be a very fine mesh, unnecessarily, but anyway, that's what you got. This is only if I ask you to refine the mesh in certain areas. And I will ask you to do things like this on your project and the final exam, etc. So then deactivate that. Now, this edge is clamp. So you go to clamp that that sector. Remember, the whole circle was clamped, but we got rid of the whole circle. So the question is, what do I do with these? These are symmetry plane. You cannot leave it alone. We talked about this thing in class last week. So you click on the surface slider, This is on a surface slider, and this is on a surface slider. You say, okay. And on that, you put a load. On that top face, you put a load, force. 500? No. 500 divided by 3. Okay? 500 divided by 3. So let me see if I can do it like this. Can I do it with divided by 3? Yep. There we are. If this was pressure, you don't divide it. But if it's force, you take a third of the model, and therefore you have to divide it by 3. Say okay. It's very good. Let's save this thing before we run it. So we go File, Save Management. Your analysis was this is the second one. I think okay, I think it's this one that's the one. This is the new one. Save as, and I'm going to call this thing. What was that? TT61. That's symmetry taken into account, basically with symmetry. Say okay, and propagate directory if needed. All right. So we're going to run it. Don't worry about this warning message. It has to do with that slider that you put in there. We got the same thing when we did the full model, and that's it. So look at the deflection. That's the way it should be, right? That's the way it should be. Here's the displacement. The result should be really reasonably close as long as you have good mesh. Again, we are not assessing accuracy here. We are not trying to compare this with the previous run that we did. Because there's more to it than we are doing in this one session, basically. And there is a von Mises stress, very small, nothing, very close to. And this patchiness means that you have a horrible mesh. Let me show you. If you go and double click on this and use a parabolic mesh, run the whole thing again, you're not going to see the patchiness there. So that checkerboard pattern means that you have a problem with your mesh, probably, as far as quality is concerned. Everything that I did requested is already in the tree. You go there, you go static solution, see the von Mises stress, right click activate. You don't see that patchiness. And notice that the numbers suddenly changed a lot. So that means that you have to be very careful in taking things for granted. And that takes care of the same problem with symmetry taken into account.